Hi, welcome to ROBOTIS Talks. This is a talk show featuring the members of ROBOTIS. Um, we're hoping to use this as a platform to highlight anything cool or interesting that we've seen being, members of the robotics and STEM communities. Hi, my name is Gavin Vleetstra. I am a technical expert and STEM consultant here at ROBOTIS. I've built rockets. I've worked on battle bots, and I've done a lot of all-around robotics. I genuinely enjoy using the servos that Robotics creates. I'm joined today by Andrew.
Hello, everybody. My name is Andrew Kreger, and I'm a technical specialist and STEAM consultant with ROBOTIS. I oversee basically the majority of our outgoing technical support and customer support for our North American branch. And I am just happy to be able to join the call and see if we can talk more about some of the interesting updates.
Additionally, we are joined today by Lucian Copeland. He is a engineer sponsored by Adafruit. He's worked on a lot of different projects in the past, ranging from a robotic arm that uses Dynamixels and mimics the movement of your own arm, to full body suits with haptics inside that allow you to feel more of what's going on inside of VR. Hi, welcome to the show, Lucian.
As David mentioned, I'm sponsored by Adafruit to work on the CircuitPython Python interpreter on microcontrollers. I've had a past of working in different startups, different robotics companies, I've used Dynamix for a really long time, and it's fun to be able to get to finally talk about it with some of the folks who are involved with that and start releasing some new libraries on new platforms. Good to be here.
Fantastic. Thank you so much for joining us. I wanted to start off by learning a little bit more on what you're currently working on. Can you give us a little bit more information on that?
Sure. So my main gig on the CircuitPython project is supporting new ports for CircuitPython. CircuitPython is a Python interpreter, as compared to something like Arduino, where you are programming essentially C++ code that is then directly compiled and put onto a microcontroller. CircuitPython is a Python interpreter that runs on the microcontroller and actually interprets Python code that you load onto a little file system on the microcontroller, and does that without having to compile anything. You don't have to you're not interfacing with all kind of the low-level nitty-gritty parts of the C code that these microcontrollers require, and that makes it really easy, and it makes it really fast to get code running on a really wide range of different platforms that we now support. So my work in CircuitPython has been mostly on the STM32 series of boards, which are kind of a very flexible range of different development boards that are also used in Micropython's or CircuitPython's sister project, Micropython. CircuitPython is a fork of an original project, Micropython, that has been made to kind of make it easier to use Adafruit boards with a Python interpreted language. And also more recently the ESP32, which is or the ESP32 S2 rather, which is a Wi-Fi enabled microcontroller.
Right.
My day job is supporting those, and in my own time I develop my own products such as the Dynamix servo community library, which lets you interface with the Dynamix servo using CircuitPython.
It's so funny. I literally at my desk, I was looking around because I bought like 35 ESP32Ss.
Oh yeah.
I was like, do I have one like on my desk ready to go? There's just such a good.
We've got a big array of them now, because we're kind of, yeah. I mean, ESP32 support is just such a huge deal right now because, obviously the ESP32 by itself is a very, very capable microcontroller. It's had a lot of attention recently, and now with the ESP32 S2, that has native USB support, which in CircuitPython is not a requirement for Micropython, but in CircuitPython it's considered to be a core part of the experience, because really the appeal of CircuitPython is that you write your code.py file, your Python file, and you save it onto the file system as if it's a flash drive, right? And so that native USB is really core to the experience. It's literally that simple. You save that file. It looks like it's a file on a flash drive, and that code is working in the microcontroller. But yeah, we have a lot of, we got the ESP32 S2 Metro Express, which is a new one. There's a Unexpected Maker just came out with a Feather Wing, or a Feather, ESP32 S2 Feather. And then obviously the Sal one. So lots of cool stuff in hardware.
Yeah, it's one of the things that, like, you know, learning the Arduino with Arduino Mega and Arduino Uno is one area like that I find very important just for, you know, hobbyist engineering. And then I've dedicated the entire rest of my time to learning ESP32 for you know, fun projects around my house, you know, adding LED lights or, you know, so sort of smart home features.
Right. It's a good platform to get into after Arduino, because it's still, even with just the C code, the you know, the raw development stuff, it's a lot easier and a lot better documented than most of the other chip lines that I've used. You know, ST, NXP, like, they're doable, but they're tough. With ESP, it's really pretty easy. Like, they make it really.
Can I ask a little bit more about CircuitPython? I just wanted to hear. You went over a few of the major differences between, you know, CircuitPython and other microcontroller IDEs, where it's a platform where it's basically a Python-based interpreter, and you make the code on your computer and then put it in, and the code is just interpreted by the Python code is interpreted by the microcontroller, and that makes development time faster. But whenever I compile the program, one of the main reasons I do it is to find the errors in the code. Right. So how is the debugging process and like the error, like location and correction process on CircuitPython?
Right. Well, that's one of the things that makes it, you know, so convenient, right? Is that, you know, for one thing, you're gonna run into errors that are a little bit less esoteric usually. Unless it's something that's wrong with CircuitPython, in which case you might have to, you know, kind of get in there and maybe even file an issue on GitHub. But, you know, as for the majority of the ports, especially our stable ones, which have been in use for a long time, all the hard stuff has really been done already. It's done by us, the Adafruit Sponsor contributors and other community contributors who have written the C code that encapsulates something like SPI communication or timers or, you know, pulse sending and receiving or audio. All of those things are written in C as a part of the, you know, what we call the common HAL, the API underneath CircuitPython, and they control these different peripherals on all these different types of chips that we support. So that's Atmel SIMD, which, you know, normally run Arduino pretty smoothly. The NRF52, which has Bluetooth, the STM32, the Sony SpreeSense, the IMXRT, and which is NXP's really high-speed new chips, and then obviously the ESP32, and some FPGA stuff, but that's not the time. So, you know, but, you know, the point is that all of that stuff works across all those different chips. And then when something does go wrong, because it's an interpreted language, you know, we have a little loop inside CircuitPython that's reading each line of code. And you can actually have exceptions in Python. You can try something and have an exception. You can have a try except statement in Python, which is, you know, lets you evaluate something, whether something succeeds or not. And that's, you know, that enables you to, you know, when you save a Python program, it has an error, you actually have communication with your device, your little serial REPL, the read, eval, print loop. And you can see what error you ran into on there. It delivers it back to you in real time. And then you can go into your code and you can fix it and you can run it again. You can see whether it still happens. And, you know, none of that, there's no compiling, there's no extra steps. You just run it and address the errors as you find them. Or, you know, if your code needs to, you can skip right past it. So, you know, it definitely streamlines that process.
as somebody that I program majoritively in C. This is like such a wild
Yeah,
a wild
it is
idea to
wild.
me.
It comes with some drawbacks, right? Like you have often a little bit less control over, the individual parts of CircuitPython. If you need a really specific function out of a peripheral, you might need to get into the C code yourself, implement it. When I first heard about CircuitPython before I was working on it, like I was a little bit of a doubter, right? It was like, oh man, because you lose some speed, you definitely lose speed when you're running an interpreter on top of everything else. You're going to lose speed depending on what you're doing. Sometimes it's not a lot, sometimes it is a lot. But once you get started and you're like, wow, I just ran through like 6 iterations of this algorithm I was trying to do to like rotate an image, and I did that in 3 minutes, as opposed to half an hour, an hour, or 2 hours, whatever it would have taken for me to compile it and agonizingly do the next thing over and over and over again.
Hit upload and then go get
You get
yourself
addicted
a
to it,
coffee. Like
yeah, right. You get addicted to the development speed. I'm telling you, like it really makes it. Doesn't make it perfect for every project. There's a lot of projects that CircuitPython is not the right pick for. I know because I run into them every day, and I have to come up with something else. I got to use the IDF, I got to use Arduino, I got to use embed, something else. But especially when you're trying stuff out, it's really pretty nice.
Got it. I wanted to talk a little bit more about the experience with Dynamixels that you've had, because you said that you had worked on them in a project previously. And I just want to hear about your experience with our like physical hardware, because it sounds like you're more of like a software side of engineering.
Well, I have always tried to like keep myself on the end of where there's moving stuff or blinking lights or something eventually, please. I try to do as many kind of hardware projects on my own as I can, just to kind of keep myself fresh in that side of it. But yeah, my first experience with Dynamixels was back in college. We were making something called the Mimic arm, which was an arm that we rigged up to a Microsoft Kinect. And it would be able to read out your skeleton, and then it would use just forward kinematics to figure out where all the points were. And that was going to be an arm that could mimic whatever you did. So you could wave at it, and it would wave back at you in real time, that kind of stuff. And when we were part of the robotics, one of the robotics groups at the University of Rochester, doing this, and everybody. If you go to one of those groups, like 99% of the servers you're going to see are those little RC servos that run off of PWM. And you really quickly run into all the things that are a pain with those. They're the right choice for some projects. But, when I found out about the Dynamixels, it was like, wow, this is like basically the same cost for some very, very powerful motors. And they have all these other things. You can tell what the torque is, you can tell what the temperature is, you can kind of handle all these exceptions, and you only need the one wire, which, is kind of the most petty thing. But, when you've spent hours and hours plugging in all the little PWM wires, and then finally you just get to like, daisy chain, a bunch of wires over, but, get to daisy chain one wire that goes to every motor in your robot, that makes a big difference. So, anyway, yeah, we used the AX12 series to put that together. It turned out pretty well. It needed to be powerful enough to lift up kind of the whole arm. This was, I think, a 7 motor arm, which is the minimum that you need to actually emulate all of the different degrees of freedom. Emulating a human arm is not really the most efficient way to build a robot arm if you want to like actually detect where the end is, because you've got a bunch of redundancy in the human arm. But you need all the extra motors if you want it to look natural. Otherwise, you're going to be missing ways that the arm can rotate. So.
Yeah, it's interesting. I definitely follow a lot of people who are trying to make like absolutely perfectly realistic hands and arms, like human arms and stuff. And the amount of things where they're like, well, now we have to add another thing that turns the hand this way, even though you have another thing that turns the arm this way and this way. Yeah. It's really interesting. And then fingers are crazy. There's so many joints. um, which is
Yeah.
which is making me sound like I'm an alien. Is
Right, right.
like, whoa, look at these
Yeah.
things.
It's funny because yeah, the human body has so much redundancy, right? And it's really, you know, when you come at it from a traditional robotics perspective, it's like really inefficient. It's just like, oh man, getting to this point is not deterministic at all. Like it's, you know, you just have to, you'd have to like pick things arbitrarily, and we're always picking things arbitrarily with our head about like where, you know, is my elbow here, is it down here? Like have a hand in the same place.
Well, what I think is interesting is like over the course of like the show, we've talked to a lot of people who talk about biomimicry. And one of the things that they say is like, you know, what's happening in nature is, you know, it's a process of learning, it's evolution over periods of time. And the thing that in nature is the reducing factor or the limiting factor is energy.
Right.
So whereas we are like, oh, 3 motors, like they can do every single motion, like in comparison, moving your entire arm versus just moving your wrist is like levels of magnitude less energy to consume. At least that's what I would believe. I could be completely wrong, and somebody could go into the comments of this video and be like, wow, look at this doofus saying something absolutely incorrect, which I hope happens. That'd be hilarious.
Yeah, well,
but that's just how I always thought about it, is that like, you know, we're built in a way where, you know, muscles contracting are our primary mode of motion.
right.
Yeah.
Well, I think any kind of naturalistic robots, which are sort of my you know personal interest, is robots that are either, you know, naturalistic in that they achieve something, or they achieve a naturalistic kind of motion, or they're expressive in a naturalistic kind of way. I'd like to think about you know, how to build robots that interact really well with human, you know, cohabitators, or you know, conversation or whatever. And you know, you have all of the different little kind of weird byproducts of biology, which, you know, at the end of the day are all probably purposeful. You know, they've stayed there somewhere through evolution. But if you miss them, you know, it takes something away from what you've built. You know, that's just as simple as like adding in the blinking to like a pair of animated eyes makes a huge difference. Adding in the extra elbow rotation on a robotic arm makes it look so much more immersive. I'm trying to figure out how I'm going to be able to make a robot do a shrug, you know, with a minimum of motors, because it's like, I don't really want to add a bunch of stuff to make it shrug. But if it doesn't shrug, you know, I can't do, you know, finger guns properly, you know. It's not gonna be able to hit some of the, you know, it's not gonna be able to like do the little, you know, expressions, verbal expressions that we do.
Yeah, you could end up in like the uncanny valley, like where it's almost almost right.
Can't
Right.
give the, you know, just I don't know expression.
I think Andrew had some questions regarding like integration of motion controls when we were talking about it.
I mean, the question that I was really interested in was, so if you had somebody who, or if you were going to be advising somebody who was interested in working with a lot of these hardware components, you know, just motion, blinking lights, trying to get into, you know, one of the, you know, basically just working with programming these microcontrollers, where would you, you know, based on your current experience and perspective, where would you recommend somebody to start? I know Arduino libraries are huge and, you know, pretty supported, and obviously CircuitPython sounds like it takes a lot of the, you know, kind of beginning uncertainty away from users. But I kind of wanted to see what you thought.
Well, you know, I used to have really strong opinions, and they change all the time. So now I'm afraid of having strong opinions, because, you know, I'm afraid I'm going to look back on myself in a year and say, oh my God, I'm so wrong. Because, you know, I used to have, like I said, I used to be kind of a doubter of CircuitPython, and now, you know, that I've worked with it and seen what other people are doing with it, it's really been like, you know, eye-opening for me, you know, how much development turnover can just impact things. You know, just being, or not developer turnover, but, you know, project iterability is probably a better term.
Right.
But you know, in terms of, I've used a lot of different APIs. I've used a lot of different chips at this point. And you know, it really does kind of depend, right? Because, you know, ESP32 is a great platform, for sure. If you're not doing Wi-Fi, then it's kind of a waste to get into this platform where at the end of the day you're going to be paying more for something that you don't need. Same with NRF. NRF is a great platform if you want to do Bluetooth. If you don't need Bluetooth, why are you using NRF, right? XRT is kind of a challenging platform. It's 500 megahertz. It's extremely fast. I mean, that is blisteringly fast we're talking about Arduino Uno is running at 8 megahertz, right? Even an STM32, F405, which has kind of been my baseline chip for a long time, that's 168 megahertz. 500 is crazy. That is really fast. But are you going to spend all the time to learn a bunch of stuff about that? About which, IMX is a challenging platform. Are you going to learn that if you don't need 500 megahertz, right? Maybe what you just need is like the absolute most boring chip imaginable, because all you're trying to do is like turn an LED on and off,
right?
Like button and do something else. So, I think that CircuitPython is nice partially because it lets you kind of pick. You can try out a bunch of different stuff, and it's all the same API. Right. So no matter what chip you have internet, you have STM32, you have, Atmel, whatever. You plug in the code and it works. You don't have to change it. You're not going to have Wi-Fi in an SPI. You're not going to have the Wi-Fi APIs on an STM32, but you're going to have SPI everywhere. You're going to have I2C everywhere. You're going to have the pulse stuff everywhere. So, I think part of just being a learning engineer is that you have to pick the kinds of projects you want to work on, and then you gotta kind of ease into learning about what chips are going to work really well for that, and what are your priorities. If your priorities is that you got to have the fastest thing all the time, and it needs to be production ready, and it needs to run on super low power for a really long time, maybe CircuitPython isn't going to be the right fit for you. Maybe Arduino isn't going to be the right fit for you. You might have to skip all the way into kind of the end how, interfaces that are, the vendor specific stuff. Maybe you just enjoy. I got a friend who loves nothing more than to just write assembly startup scripts for chips. He's just into it. He just loves doing it.
Likes writing assembly.
Different folks, are just into different things. So
yeah,
it's hard to answer that question super specifically, but I hope.
No, I think that's honestly a great way to answer it, and something that I think a lot of people don't realize when they're looking into these kind of things. It really does sound like the biggest determinant on what you want to work with is what you want to do, right? But it does sound like the CircuitPython is a good option for if you aren't quite sure if you think you might want to move over platforms, because all those functions still remain the same.
Right.
I guess kind of related to that. So I know that CircuitPython, of course, was developed for more of the Adafruit supported projects, right?
Good extent, yeah.
Right. And so in that case, I know this might be a little hard to speak on or to really mention, but would you say that somebody who's become familiar with CircuitPython would be able to go and try a project in Micropython with minimal changes needed, or vice versa? Do you think they're relatively?
Yeah, I think the differences between the two projects, so the Micropython core Python interpreter is pretty much the same as CircuitPython, and the two projects are friendly. Like my Scott, who's in charge of kind of the CircuitPython development, regularly talks to George, who's kind of the main Micropython guy, and they exchange ideas and all that kind of stuff. I think I haven't used Micropython much myself, I think I'm not sure of all the little differences. I think that one of the big important things between Micropython and CircuitPython is that there's the API in CircuitPython is the same across all of the different platforms that are supported. So, SPI is going to work the same on, STM32 as it's going to work on ML and as it's going to work on Enterprise and all these other things.
Right.
That's not necessarily true, I don't think, for MicroPython. MicroPython, I know in a lot of ways is faster. And has more capabilities in certain areas. It's a little bit less aimed at the kind of beginner folks and kind of specific things that CircuitPython can be at times. So I think that that's again something that you'd have to evaluate on a per project basis, but which one is right for you. But at the end of the day, you're using Python on both. It's a subset of CPython on both, and really the things that are going to be changing are what you're using are going to be the modules that you use, right? So there's an SPI module. The Python's not going to change. The Python's the same everywhere, right? But the module, the SPI module, it might have some different parameters, that kind of stuff. But yeah, that's I wouldn't regard that as being like a really huge obstacle. And a lot of this stuff is going to be facilitated through tutorials and documentation, which you're going to have to read wherever you are. So
No, absolutely.
Yeah.
Okay,
Yeah.
no, thank you for that. I think that's just really interesting perspective, and it's just good for my own reference too, because I know that a couple of our examples for one of our newer platforms, the Engineer Kit, have started to add a couple examples that are actually available in MicroPython for users who are interested.
Right.
So,
right.
I think it's good just for people to be aware that if you are experienced in one, that there is not a high barrier of entry to the other.
Right. Yeah, and I think it's important to just to kind of on both of these questions, people have to evaluate for themselves what their personal goal is, whether that's, and I think that the biggest two goals that you might be able to have are, do you want to get this project done as fast as possible, or are you trying to actually like learn about something really in an in-depth way and kind of add that to your skill set, right? And you're going to have overlap of those two things because you're always going to want to finish something, I hope, and then you're always going to be learning stuff. But they can be at kind of different levels of priority. Like if you want to just be a better developer, well, maybe you should just sit down with some C code and try to kind of implement one of these low-level drivers. And that's probably going to, you're probably going to learn a lot from the process. If you want to just get something together and it's got a lot of different parts, it's got a lot of libraries, a lot of different, it's got like a clock and a motor and a this and a that, if you write all that from scratch, it's going to take you, months. Like you might just not have the time to do that. And so in that case, you're going to want to look into a project that supports all of the stuff that you need. And then you can, and hopefully lets you bang it out quickly. And so, if you're building a project that has a lot of Adafruit parts, and they're all very different, and you don't want to rewrite the drivers for all of them, I would say that CircuitPython is going to look pretty attractive. If you're trying to kind of really get into optimized code and really understanding the super in-depth parts of everything, you could still work on CircuitPython, but you might be actually doing some development for CircuitPython, contributing to the repository. But also, if you chose, you could go check out MicroPython and you could, do work there, or you could just forge ahead with, the low-level code. I think that it depends a little bit on your priorities as well.
Yeah, it's interesting to think about, because when it comes to these sorts of questions, it's in my mind, there's really two directions you can go, right? Where in the beginning, if you just want to get something done, I would always think of like a higher level programming language like Python or C as being like my go-to for getting things done. But when I talk to people who like really know their stuff, they're like using low level programming languages to do things on computers and Arduinos that I cannot even imagine doing, because they're like, well, we just want it to be the fastest, the best. So we're willing to spend all of this time learning like the exact firmware address inside the Arduino, or the assembly code for the computer or chip or whatever it is, to make it run as best and as fast as possible. Optimization of space, speed, things like that. But it really is like a big decision on what your kind of project you want to be. You know,
Yeah.
if you're trying to write a code for a video game and then put it onto like a QR code, which is a video I've seen on YouTube, you know, you're talking about assembly code there because it's so much data in such little space. You have to write it in a extremely difficult language.
Right. Well, we're getting better microcontrollers all the time, so that gets less. I mean, we talk about capable computing. You know, we're just packing more and more memory on, more and more features. I mean, you know, some of these upcoming ESP32 chips are just they're kind of gonna have it all, right? But you know, I think I don't think that there's one thing I would stress that I do stress to just all the folks that I make in Makerspace who are getting into Arduino and stuff is that you should definitely not feel like ashamed of not wanting to become an embedded engineer if you don't want to be an embedded engineer. Being an embedded engineer is something that's super specific. And, you know, if you want to be a data scientist, you want to be, you know, a robotics person, you know, you want to, you know, be a hardware developer, you know, you learn the bare minimum that you have to. And, you know, you can kind of sometimes get advice from folks who are embedded engineers. It's like, you have to do it this way. It's like, do it the easy way. If you don't want to be an embedded engineer, do it the easy way. Like, don't worry about, you know, what these old guys are, you know, have like, you know, 50, 60 years in the industry are going to be telling you about your priorities, because they're going to know their stuff really well. And they're telling you what's good advice if you did want to become an embedded engineer. But yeah, that might not be the priority for you. So I think everybody has to choose that for themselves.
Yeah, it's interesting. All right, you mentioned the like makerspace. Are you active in the maker community?
Yeah, so you know, I don't know that anyone is super active in the community right this second, for you know, for obvious reasons. But I still did and still do a good amount of my work at a big makerspace in Cambridge, Boston, called Artisans Asylum. So it's a 40,000 square foot location. It's one of the biggest makerspaces in the country. It's got woodworking. It's got just about everything that you could ask for. It's got a woodworking shop. It's got a metalworking shop. It's got welding stations. It's got a whole electronics, you know, and robotics area. It's just, you know, and it's filled with people who are using all of those almost like on a full-time basis. The people running their whole businesses out of it. So it's been really fun to you know, get to see that, and kind of, you know, yeah, bring some of what I'm working in, share it with other folks who are doing other things. That's where I met Cosmo, who does the Turtlebots. So yeah, and you know, I'm always thinking about ways that, you know, you can bring, because I've been at other makerspaces. I was at Seattle Makers for a little bit. I've been to makerspaces in San Francisco and Austin. And they're all really cool spaces. Not all of them are as huge and kind of, you know, hyper organized as Artisans Asylum. So yeah, always cool to see what people are working on.
Yeah, I think in one of our emails we were talking a little bit about it, and I've worked at a makerspace before, and I think it's such like a unique and good experience for anybody who's an engineer to like get your hands on that kind of stuff, because, you know, I now know how to do CNC machining, CAD design, and as well as electronics, which is kind of what you were talking about, where it's like if you have a project that you want to do, like you will learn how to do those sort of specific things, like whatever tool that you need, you'll learn it. So it's kind of just one of those, it's definitely an interesting research that I wish more people would utilize.
Yeah, well, it's a great place to pick up some of the contextual stuff that we've been talking about too, you know, not just like what are the specific skills that you need, but like what's a good skill to learn, right? Like, what's a strategy if I want to be, you know, in robotics or
Where do I
whatever it is you're doing? You know, you'll get a lot of opinions. Some of them will be wrong, but you'll get a lot of opinions.
You'll hear from a lot of different kinds of people,
Right.
if working at a makerspace or working in a makerspace.
Right.
I know that you were working on, I think, like a kind of featherboard for Dynamixels, and you talked about making a Dynamixel library.
Yeah, right. So I actually have the system here. So I you know, just to kind of demonstrate kind of the power of the REPL here. I don't know how easy it is for me to share my screen, but you know, just using the REPL, you know, it makes it trivial to to just run commands to an individual motor. And, I didn't have to program, when I'm using Python, you don't have to actually, a Python interpreter like this, you don't actually have to program, a message interpretation system where you plug in the number and then the motor goes to that number or anything. You can just kind of run your code line by line in the REPL interpreter, right? So you open up a serial connection, it reads out, hey, here's CircuitPython, here's the prompt, and you can just type lines of code in there and it's going to run. So that's kind of a cool way to do it. But, that's been running off of this little guy, which is, my feather, kind of calling the Dynafeather, which is currently running off of a, so this is underneath. Feather, by the way, is just a kind of an Adafruit promoted standard for development boards. So it's just, it kind of has these two set rows of pins that have the same functionality fit across all feathers. So you can use the same feather wings. There's a lot of different feather wings. Here's one that's got a bunch of the NeoPixel LEDs on it. You can get them for screens. You can get them for data logging, UPS, or not UPS.
We've got one of those for Raspberry Pi.
Yeah.
Like the
longitudinal tracking, pressure, all that kind of stuff. So, the one that I built so this is an STM32 featherboard, which has that STM32 F405. It's a pretty powerful chip.
Is that USB-C?
I know. I'm also stuck on the USB-C.
Oh yeah, it is. Yeah. So a lot of Adafruit boards have been switching over to USB-C recently. I think mostly just for the durability. We're not using the high-speed stuff. Or
it's just the connector.
I don't design.
Makes me happy to see.
Yeah. So this is the Dynafeather. So it's got a couple of out ports for the Dynamix. So, one of the things that I think, when I was first using the Dynamixels, one of the points that I kind of had a hard time converting people on is like, what do you mean I can't just plug it into my Arduino Uno? It's like, because you've got
the half duplex.
The half duplex UART, and you have to have some buffers. So this is just kind of trying to make that as easy as possible. It's got the buffer chip right on there.
Yeah,
it does all that stuff for you.
Can I ask what is that a jumper, the yellow piece, or is that a dip switch?
Oh, the little yellow, yeah. So that allows you to have two options to avoid kind of conflicting power sources. You can plug in with a 12-volt cable here. You could attach a battery just to the little screw down header here if you wanted instead. And then the jumper lets you pick what the power source for the actual processor feather uses. So if you want, you can, without having it connect to the computer, you could program it with the computer, but then you can disconnect it from the computer and just have it run totally autonomously off of the same source that's powering the Dynamixels. So there's a power adapter that'll bring it down to 5 volts, so that they can feed into the feather and power that as well. So that's just a jumper for picking kind of which power source the feather processor is using. Is it going to use USB or is it going to use your main power source? And then there's also a couple little jumpers that change what pin on the feather layout you're using. So other feather, you might want to use it in a stacked. You can stack feathers, right? So you can put a whole bunch of them on the same chip. So
question.
Yeah, if you wanted to use it with a screen, and you had more stacking, you can take like a third one and fit it in here, and depending on what pins that one uses, you might want to reconfigure the feather to use something else. So this is a screen. Doesn't make a lot of sense to put where I put it.
Proof of concept.
But yeah, or an ESP32 coprocessor, or there's a new ESP32 feather out by an unexpected maker, so you can make a totally wireless robot powered off of some 12-volt battery, and control all your Dynamixels wirelessly using the same stuff. So
cool. Well, this has been a really interesting conversation that we've had. I've learned a lot about more than I thought I would about microcontrollers and programming using Micropython. So thank you for that. Is there anything that you would like to shout out or plug currently? I know that you're we talked earlier, and you're trying to get more into like education or sharing projects.
Yeah, well, I think right now everything is slowed down a little bit. Hopefully, I will eventually have this Featherwing out on Tindy or some other place that if people would like to use it, I'll have it out. But I think that the big thing is just the Dynamix sole library will work with or without the feather. It doesn't need the feather to do it. You can rig up a Dynamix sole to a any CircuitPython board, whether it's Adafruit or not, whether it's your own. You can make your own CircuitPython board definition if you want. But all you need, really, I think, is a diode and a resistor to be able to emulate your own half duplex system. And I've got a little guide on my library page for that. So yeah, if anyone would like to try that, it's in the CircuitPython community bundle, the Dynamix sole, and also under my GitHub tag, which is Hyrofect.
Yeah, and I think we can definitely make sure we share a link also in our description here. So anybody who's watching, please do check the description, and we'll make sure we have that information there for you.
So yeah, and of course it's all permissively licensed. That's the license I use on everything that I do. So you can use it if you're a company or whatever it is. If you find it useful, I hope people get a kick out of it.
Got it. All right. Well, I'd like to thank everyone that's watching. If you have any comments or for future videos or anything that you'd be interested in seeing in the future, please comment down below. Like and subscribe this video. It really helps our channel out. You can follow us on Facebook, Instagram, and TikTok under ROBOTIS America. And I hope you all have a fantastic day.